Hello everyone. Today we are going to talk about Messier Object 1, also known as the Crab Nebula. The common name comes from a drawing that somewhat resembled a crab with arms, produced by William Parsons, 3rd Earl of Ross, in 1842 or 1843, using a 36-inch telescope. The nebula was discovered by English astronomer John Bevis in 1731. It corresponds with a bright supernova observed in 1054 CE by Native American, Japanese, and Arabic stargazers. This supernova was also recorded by Chinese astronomers as a guest star. The nebula was the first astronomical object identified that corresponds with a historically observed supernova explosion. In late 1758, while looking for the predicted return of Halley's comets, Charles Messier found the Crab Nebula, which he initially thought was Halley's comet. After some observation, noticing that the object that he was observing was not moving across the sky, Messier concluded that the object was not a comet. Messier then realized the usefulness of compiling a catalogue of celestial objects of a cloudy nature, but fixed in the sky, to avoid incorrectly cataloging them as comets. This realization led him to compile the Messier catalogue. In the early 20th century, the analysis of early photographs of the nebula taken several years apart revealed that it was expanding. Tracing the expansion back revealed that the nebula must have become visible on Earth about 900 years before. Historical records revealed that a new star, bright enough to be seen in the daytime, had been recorded in the same part of the sky by Chinese astronomers on 4th of July 1054, and probably also by Japanese observers. In 1928, Edwin Hubble proposed associating the cloud with the star of 1054, an idea that remained controversial until the nature of supernova was understood, and it was Nicolas Mayol who indicated that the star of 1054 was undoubtedly the supernova whose explosion produced the Crab Nebula. The search for historical supernovas started at that moment. 7 other historical sightings have been found by comparing modern observations of supernova remnants with astronomical documents of past centuries. During the first or main stage, a star fuses 2 or more hydrogen atoms together. The result is a lot of energy being expelled in different form, including light. As the hydrogen gets transformed into heavier elements, such as helium, lithium, carbon, and so on. The star starts a series of phases where its volume and color start varying. Has it changed the main fuel from hydrogen to those heavier elements? However, once it runs out of silicon to turn into iron, a process that only takes a few hours, the star collapses on itself at about 1/4 the speed of light. The upper layer of the star bounced back on the core in a massive explosion, the supernova, ejecting all the gases of the upper layer, giving us the remnant or nebula. In the center of the nebula, we have now what is left of the core of the star in the form of a pulsar. The Crab pulsar, a neutron star 28 to 30 kilometers across with a spin rate of 30.2 times per second, lies at the center of the Crab Nebula. It emits pulses of radiation from gamma rays to radio waves, thus ionizing the gases and making them emit light. The color of the gases varies depending on the nature of the gases. In 3 dimensions, the nebula is thought to be shaped like an oblate spheroid, 6,600 light-years away. The filaments are the remnants of the progenitor star's atmosphere and consist largely of ionized helium and hydrogen, along with carbon, oxygen, nitrogen, iron, neon, and sulfur. The filaments' temperatures are typically between 11,000 and 18,000 Kelvin, and their densities are about 1/300 particles per centimeters cube.
The nebula is about 11 light-years across and is expanding at a rate of approximately be 500 kilometers per second. Almost 1,000 years after the supernova, it has now started to slow down its expansion. It is hard to calculate the initial expansion, but it is evaluated to be around 10,000 to 30,000 kilometers per second. That is all for today. If you liked this video, please press the thumbs up and don't forget to subscribe.